Hello again, dear grade 11 students. In this part, we are going to know how to find the roots or the numbers given their sum and product. So don't forget, first of all, we have to remember that x squared minus sx plus p equals 0. So we can use the sum and the product to form the quadratic equation in order to calculate the roots. Now here the given is that s is 7 and p is 6. So just applying this formula, I'm going to get x squared minus 7x plus 6 equals to 0. Now let's start solving this quadratic equation to get these roots that are 1 and 6. Notice the remark we mentioned previously that when a plus b plus c equals to 0. Now here a is 1. So let's check. 1 minus 7 is minus 6. Minus 6 plus 6 is 0. Then since a plus b plus c is 0, one of the roots is definitely 1, if you remember. Let's remember this idea. And the other root, who remembers? If one of the roots is 1, the other is c over a, which is, as you see here, 6 over 1, which is definitely 6. So the roots are 1 and 6. If you don't want to use this method, you can use delta. You can find delta, which is equal to b squared, means minus 7 squared, that is 49, minus 4 into 1 into 6. So minus 4ac, so 4 into 1 into 6. So it is 49 minus 24, which is 25. Then 25 is positive. Surely this equation has two distinct real roots. One of them is x prime, which is equal to minus b, means plus 7, because b is minus 7. Then minus 7 is plus 7, plus a radical of 25 is 5 over 2a, which is 2 over 1. Then we will get 7 plus 5, which is 12 over 2, which is 6. This is the first root, and the other root is similar to the formula of the first root, but we have to put minus radical delta. So 7 minus 5 over 2, which is 2 over 2, which is 1. So that's where 1 and 6 come from. So either we use the method of a plus b plus c equals 0 if it happens here, or we just use delta, or we can use the help of the calculator. This is example 2. The sum is 2 radical 3 and the product is 2. Also applying this formula, we will get x squared minus 2 radical 3x plus 2, and using delta, x prime and x double prime, we are going to get the roots x prime and x double prime. Now notice here that it's not necessarily to arrange them. For example, if x prime is 6 or x double prime is 1, it's the same as if x prime is 1 and x double prime is 6. Now let's continue training exercises to know how to benefit from the sum and the product. Find the length and the width of a rectangle whose area is 21 and whose perimeter is 20. So let x prime be equal to the width and let x double prime equal to the length. The area is 21. What's the area of the rectangle? It's w times l, or l times w, whatever, the length times the width. Then x prime dot x double prime is 21. So this is the product. X prime dot x double prime means that the product is 21. So this is what we care about. Now we still need to find the sum. The sum is related to the perimeter. The perimeter is 20, means 2 into, this is the perimeter of the rectangle, double the length plus the width is 20, then surely w plus l is 10. So 2 into x prime plus x double prime is 20, then surely x prime plus x double prime is 10. So this is the sum. So I've got the perimeter, I've got the product, and the sum. Thus, applying the formula x squared minus sx plus p equals to 0, I'm going to get x squared minus 10x plus 21 is 0. Using delta and calculating the roots, I'm going to get 3 and 7, and of course those are logical numbers because the length and the width are going or must be positive values. Let's see another training exercise that's very important. Here we go. Example 4. E equals x squared minus 5x plus 4 equals to 0. So this is the equation, the quadratic equation, that's x squared minus 5x plus 4 equals to 0. Verify that E admits two distinct real roots, x prime and x double prime. How to verify that one? Let's think a little bit. We just proved that delta is positive. So we are going to find delta and prove that delta is positive. Whenever delta is positive, then definitely E admits two distinct real roots. Let's continue reading the question. Without calculating the roots, x prime and x double prime, we have to evaluate all of these. So let's start. First, let's prove that delta is positive. A is 1, B is minus 5, and C is 4. Then delta is B squared minus 4AC. So it is minus 5 squared minus 4 into 1 into 4. Then it is 9. Positive. Then E admits two distinct real roots. So we finished part 1. Let's talk about part 2, which is the most important part in this training exercise. We have to find x prime plus x double prime without calculating any of x prime or x double prime. So what does x prime plus x double prime remind you of? It's definitely the sum. And the sum is equal to minus b over a. So don't forget, the sum is minus b over a. Then what is minus b? B is minus 5. So minus b is 5. Minus into minus. Over a, which is 1. Thus, the sum or x prime plus x double prime is 5. Now also required to find x prime dot x double prime, which is definitely the product. And the rule of the product is that it is equal to c over a. What is c? It is 4 and a is 1. Then x prime dot x double prime is 4. So the sum of the roots is 5, the product of the roots is 4, and we are going to use these in the coming parts. Now in part C, we have to find x prime, x double prime squared plus x double prime into x prime squared. So first of all, we can take common factors, x prime and x double prime. So we take common factors, x prime into x double prime. What remains inside is x double prime plus x double prime. So notice, we can take x prime and x double prime as common factors. Here remains x double prime and here remains x prime. So we get p outside into s. Then p into s means 4 times 5, and the final answer is 20. So this value is equal to 20. Now what about 1 over x prime plus 1 over x double prime? Whenever we see fractions, all what we think about is same denominator. We have to make the same denominator. So we multiply this by x double prime up and down, okay? And we multiply this by x prime up and down. So we get x double prime plus x prime over x prime x double prime. Then it is s, this is the sum s, over p. S is 5 and p is 4, thus we get 5 over 4. And finally comes x prime squared plus x double prime squared. So here we have to remember the identity that says that a squared, let's remember, a squared plus 2ab plus b squared is equal to, as you see, a plus b all of it squared. So a plus b all of it squared is equal to a squared plus 2ab plus b squared. Then a squared plus b squared alone is as if there is here plus 2ab, and we take it to the other side. So a squared plus 2ab plus b squared is a plus b squared. Then a squared plus b squared alone is by taking 2ab to the other side. So a squared plus b squared is equal to a plus b squared minus 2ab. And you can use this as a formula. Okay? So a squared plus b squared is a plus b, all of it squared, minus 2ab. And we can apply this same idea on x prime squared plus x double prime squared. So x prime squared plus x double prime squared is x prime plus x double prime squared, as if we are replacing a by x prime and b by x double prime, minus 2 x prime into x double prime. Now we have x prime plus x double prime, which is s, and just we have to square it, then we get s squared minus 2p. So this is a rule that you can use it all the time, that x prime squared plus x double prime squared is s squared minus 2p. S is 5, 5 squared minus 2 into 4, then 25 minus 8, which is 17. So 2 into x prime x double prime is 2 into 4, and s squared is 5 squared. So again and again, x prime squared plus x double prime squared can be used as this formula all the time, s squared minus 2